I've got a brief discussion to have here, and then we've got some questions to go over. So if you look at the end of the booklet that I've given you, we've got here 5 questions that I've pulled out of the revision guide. And some of these questions you have seen before, but I want to talk about when should we use differential calculus techniques and when should we use integration techniques, because I think that's a pretty key tell. So that's our plan today. Tomorrow we'll have class pay. All right, before lunch, so sort of bring your own food. I'll bring a few things, but you can bring some. And then on Friday, we're going to do something similar to this, but with statistics. So with discrete and continuous. So trying to discover which techniques we should use where. So let's get straight into it. Okay, today calculus versus integration. When we've got a calculus question, these are some of the tells that we should be looking for. We're starting with some quantity. All right, so we can think of a number of examples: height of a tree, people at a party, whatever it is. All right, we have some function, and often we're asked to perform some basic calculations for a period of time. How tall is the tree initially? How tall is it after 5 years? All right, and all you're doing is putting the time value into the equation. And then what they tend to do is they move from some quantity function to a rate. And so you get asked these kinds of questions. How fast is it growing when time is 5? How fast is it changing? When is it growing fastest? Okay, those kinds of questions. They're about rate, right? And so what is the rate? So to move from a quantity to a rate, we have to differentiate. If f of x is the function, f dash of x describes the rate at which f of x changes. And then some two key points for you. So the turning points of f of x. So that's like local max, local min, when the height of the tree is the max, when the number of people at the party is maximized. They occur when the first derivative is 0. All right? But then when is the rate maximized? When does the maximum rate occur, the maximum rate of change? Well, that's when the second derivative equals 0, right? So yeah, 2 key points there on that. So that's some calculus. When we look at integration questions, they will start with a rate. And often they define it like this, like dh on dt, or h dash of t. Maybe not, maybe it will just be a function. But it describes, always, you'll see that word, rate. This is the rate at which something is happening per period of time. It's the rate at which something is happening. And they might ask you some questions to begin with, like if you put a time value in, you know, if you put time is 5 in, that's going to tell you how fast the tree is growing when time is 5. And they get you to move from the rate to the quantity, because the area under the curve of a rate function is going to be the quantity that occurs between time period A and time period B. So if we do the integral from A to B of h dash, where h dash is the rate at which the tree is growing, that's going to tell you how much. Okay, if you move from a rate to a quantity, it's going to tell you how much the tree has grown. Okay, over here we have, here's the height of a tree, and we go to the rate that tells you how fast the tree is growing. Okay, so quantity, how much, what's the magnitude that it's grown, and then here, moving from a quantity to a rate, how fast is it growing per some period of time. So that's the difference, right? So we've got 5 questions here, and all I want you to do to begin with is have a read through with them and assign either a C for calculus or an I for integration. And I'll just come around and make sure we're all sort of on the same page with that. And then I encourage you to have a go at some of these questions. Okay, so that's probably where I'd like us to direct our efforts today. Before we do that, are there any questions about anything I've set up here? Very good. So that's our plan today.